when we're doing proofs, we're using the law of attachment. So if you have a true conditional statement and we have some conditions that satisfy the conditions for that true conditional statement, we go ahead and make the conclusion of it. So what we're looking at when we're doing these proofs is we're looking for, like for here, if we're given angle 1 is a right angle, we're looking for what conditions does that satisfy? Where's the true conditional statement that angle 1 is a right angle satisfies? And you have a sheet that has a bunch of true conditional statements on them, so find that. And really, for these vocab proofs, a lot of them are just the definitions of that particular vocab word. So here the vocab word is right angle. What is the definition of a right angle? We'll look on that sheet and see that. Okay, so what is that arrow pointing to, or where direction is that going? Where is that leading you to? If we know something's a right angle, then what? Well, to be a right angle, it means it equals 90. The measure of angle 1 is going to equal 90 degrees. We know that it satisfies the conditions for that definition, so we make the conclusion of that definition. And then kind of check that off. Well, that got us somewhere. What about the second thing we're told? Angle 2 is a right angle. Well, in the same step, we can actually say that measure of angle 2 is 90. We're using the same reasoning, so we're going to use the same step to do it. Statement 2, measure of angle 1 equals 90, and measure of angle 2 equal 90. And we're supposed to somehow prove that 1 and 2 are the same, that they're congruent. And I think you're okay with saying that they're going to be the same, they're both equal to 90, but how do you say that? What are we actually doing? And if you need to pause the video to kind of process that, to try to figure out what is going on, what could I use to justify, what type of theorems or definitions do I have to justify that 1 is going to equal 2, maybe you can do that and then look down your sheet and find that. It's going to be replacement rule. So why do you suppose we can use replacement rule? What would we be actually replacing? You can actually start with either equation. So sometimes when I'm doing this, I'll actually just say, you know what, pick one and replace. So if we pick this first equation that we had, measure of angle 1 equals 90. Well, can I replace the angle 1? I don't know what else it equals besides 90. Can I replace the 90? Sure, you could replace that with angle 2. We'd get a new equation just like we stated. Or if you wanted to do the second one, you replace 90 with measure of angle 1. But then we'd have it in the wrong order that we wanted. We'd use symmetric property. But replacement rule will justify that new statement. And then all that's different in this formal proof is saying that angle 1 is congruent to angle 2. But in a formal proof, we want to make sure that we state exactly what they want us to state and have a reason for that. So what does it mean to be congruent? Well, it means all the measures are the same. So to prove something congruent like we're doing, you have to show that all the measures are the same. And for angles, there is only one measure. So to show all the measures are the same for angles, you only have to show one measure, and then they're congruent. That's definition of congruent angles is what we've been writing down, or what we're going to write down. When we know that all the measures of the angle, well, that one measure of the angle then is equal, to change it to congruency.